I want to introduce today Violina Popova. Thank you, Violina, for joining us today. Violina is a seasoned software developer with a focus on the mobile app development dedicated to providing a seamless cross-platform experience. Her journey in the tech industry began in consulting before the transition into programming. With expertise in React, React Native, TypeScript, Firebase, and Next.js, she excels in both mobile and web application development. Violina, stage is yours. Thank you so much for joining us today.
Thank you for the introduction, Mariya. Let me just share my screen. I hope you're all seeing my slides. Perfect. Hello, everyone, again, and welcome. I'm so glad to see you all here on our second session of design patterns in JavaScript. Last time, we kicked things off by diving into patterns focused on object creation and organization. Remember the factory, prototype, and module patterns. We talked about how they help us build flexible objects and structure our code more effectively. Today, we are shifting gears a bit, but we are still focusing on something absolutely crucial for any growing front-end application: managing relationships and communication between our components. Think about it. As your code base grows, your components aren't just sitting there in isolation, right? They need to talk to each other. If you don't have a solid strategy for that communication, things can quickly turn into what we affectionately call spaghetti code, a tangled mess where a change in one place unexpectedly breaks something somewhere else. It becomes a nightmare to debug, incredibly hard to scale, and honestly, no fun to work with. That's exactly why we are here today. We are going to explore some design patterns that help us build cleaner, more efficient, and more maintainable communication channels. We'll be looking at observer, mediator, and middleware patterns. These are game changers for keeping your component interactions orderly and scalable. Let's start with the observer pattern. This is a fundamental pattern. Once you grasp it, you'll start seeing it everywhere in your JavaScript work, even if you don't always call it by its formal name. So what exactly is the observer? At its core, it's a one-to-many dependency relationship. Imagine you have an object. We call it subject, and it has a state that other objects might be interested in. These interested objects are called observers. The magic of the observer pattern is that whenever the subject state changes, it automatically notifies all its registered observers. The observers then react to that notification, usually by updating themselves or performing some action. Think of it like this, and this is a classic analogy: a newspaper subscription. The newspaper publisher is our subject. They produce content, they publish new editions. You, as a subscriber, are an observer. You've explicitly signed up to receive updates from the publisher. When a new edition comes out, the publisher's state changes. They don't have to individually call every single person. They simply publish the new edition, and all the subscribers who signed up automatically receive it. You don't know who else is subscribing, and the publisher doesn't care about the specific details of how you read your newspaper. They just notify everyone who's listening. That's the essence, the coupling. The subject doesn't need to know the concrete details of its observers. It only has to know that they have a method to be updated, and the observers don't need to constantly check the subjects. They just wait to be notified. Now, why this is so powerful in front-end development? We are already using it extremely perhaps without realizing it. And the first thing is event handling. This is the most common. When you do add event listener, for example, to a button, like when you're handling the click, your button is the subject and handle click is the observer. When the click event happens, the button notifies all functions listening for that click event. The same applies to form submissions, key presses, mouse movements, all based on the observer pattern. The next use case is simple state management. For smaller applications or specific components, you can use the observer pattern to build reactive UIs. Imagine a global store object that holds some application state. Components can observe changes in that store and re-render themselves when data updates. The next use case is for custom events. Need to signal something specific across different parts of your application? You can create custom event systems that leverage the observer pattern. For instance, a data fetching module might notify listeners when data has successfully loaded, or an animation module might notify when an animation completes. And another use case is UI updates based on data changes. When a piece of data changes, for example, a user's name updates, multiple parts of your UI might need to reflect that change. For example, a profile header, a user list, a welcome message. The observer pattern ensures all these dependent UI elements are updated automatically. Now let's see what are some of the advantages but first, before continuing with the advantages, I would like to show you a simple app which I built for this session, and just quickly go through the code. So this is the UI, and now we are going to dive into our code. We have a data publisher class, which represents the subject in the observer pattern. This class manages a list of subscribers and notifies them for new data. It stores the observer functions and callbacks. We have a list of subscriber functions, observers, and it provides a method to subscribe, unsubscribe, and publish data to all subscribers. Here, the subscriber method adds a new subscriber to the list if it's a function and not already subscribed. And it returns an unsubscribe function specific to the subscriber. The unsubscribe method removes a specific subscriber from the list and also is warning the console for attempt to unsubscribe a non-existent subscriber. Next, we have the publish method. Here, it calls each subscriber function with the new data and notify all subscribers when a change occurs. And of course, we are handling the error if there was an error notifying the subscriber. The first thing which we are doing in our observer is to create a single instance of our publisher class, which is here by defining the constant data publisher. The next thing is we are getting references to our HTML elements from the DOM using their IDs. We are doing this here, and this is our HTML file. Here you can see our HTML elements. We have data input, we have publish button, we have another unsubscribe display button, and they are visible here. This is the input field, this is the publish new data button, and this is the unsubscribe. Once we get the reference to our HTML elements, we should define our observer functions that update specific DOM elements. And we are doing it here. First, we are defining the function for the first element. Then we are defining the observer function for the second element and for the third element. And this is our state for the observer for the third element of our observer. We are also console logging when new data has been published. And what we are doing additionally, we subscribe the observer to the publisher. And you can see it here in the console. Let's try to publish new data. New data has been published and it's been updated in our UI. We can also unsubscribe. And we will no longer receive updates for this specific element. We are also adding event listener to the publish button, which we are doing in this block of code. On click, we are adding our event listener, and we are also clearing the input after publishing. And finally, what we are doing, we are adding event listener for unsubscribing display. We use the unsubscribe function returned by the subscribed call, and also we are disabling the button after unsubscribe. Finally, what we are doing, we are sending an initial message to all observer to show the starting state. And this is our simple example of observer. Moving forward, let's talk about the advantages of our observer. And why you should use it actually. The first thing is the coupling and the loose coupling. This is the big one. The subject and observers are highly independent. The subject doesn't know details about its observers, and the observer only know about the subject through its public interface. Subscribe, unsubscribe, update. This makes your code more flexible and easier to change. The next advantage of using observer is reusability. Both subjects and observer can often be reused in different contexts as they have fewer direct dependencies. And flexibility. It's easy to add new observers without modifying the subject and vice versa. This supports open-close principle, open to extensions, closed for modification. We saw the advantages. Let's see the disadvantages. Debugging can be tricky. In complex systems with many observers, it can sometimes be challenging to trace the flow of execution and understand why a particular update happened or why an observer wasn't notified. Potential for memory leaks. If an observer subscribes to a subject but never unsubscribes, especially if the observer itself is removed from the DOM or goes out of scope, the subject might still hold a reference to it. This prevents the observer from being garbage collected, leading to memory leaks. This is why unsubscribe is so important. And finally, order of notification. The order in which observers are notified is usually not guaranteed unless explicitly managed, which can be an issue in scenarios where execution order matters. Despite the cons, the observer pattern is incredibly powerful and widely used. It's the foundation for many reactive programming paradigms and event-driven architectures. All right, we've seen how the observer pattern helps decouple a subject from its many observers. It's great for one-to-many communications, but what happens when you have many components and they all need to talk to each other in complex ways? If every component knows about every other component it needs to interact with, you end up with a tangled web of direct dependencies. That's where our next pattern comes in, and this is the mediator pattern. The mediator pattern introduces a central object, the mediator. It manages communication between a set of objects. Instead of objects, which we'll call colleagues in this context, communicating directly with each other, they communicate through the mediator. The mediator then decides how to route or handle those communications. Think of our classic analogy here, an air traffic controller. Planes are our colleagues or components. They need to coordinate their actions, takeoff, land, hold. The air traffic controller is the mediator, manages all traffic in the air, runway status, and directs planes. When a pilot wants to land, they don't directly radio other planes and ask, "Hey, is the runway free?" That would be chaos. Instead, the pilot communicates their intention to the air traffic controller. The controller knows the status of all planes, runways, and other relevant information. The controller then tells the plane when and how it can land, perhaps relaying instructions, and that affects other planes, but the planes themselves never talk directly. This is the core idea. The mediator centralizes complex communication logic, reducing direct dependencies between components and simplifying individual component responsibilities. Let's see some of the use cases in Frontend. And where do we see the mediator pattern shine? The first thing is complex forms with interdependent fields. Imagine a registration form where selecting a country affects the available states, provinces, which then affects valid zip codes and perhaps also displays a different shipping method. Instead of each input field needing to know about and directly interact with all other related fields, they all send their changes to a mediator. The mediator orchestrates the updates across all relevant fields. The next use case of mediator is in managing interactions between different widgets on a dashboard. Consider a dashboard with a chart, a data table, and a filter panel. If you click a bar on the chart, the data table should update, and the filter panel might highlight the corresponding filter. If you apply a filter, both the chart and the table update. A mediator can manage these cross-widget interactions, preventing each widget from needing explicit knowledge of the others. And the final use case is in orchestrating workflows involving multiple components. In multi-step wizards or complex processes, different UI components might be responsible for different stages. A mediator can manage the flow, ensuring each component performs its part and signals the completion of the mediator, which then activates the next step or component. The key benefit here is that components become simpler and more usable because they don't need to know who they're talking to or how their messages are processed. They just talk to the mediator. And now let's see this with code example. Again, here for the mediator pattern, I have created a simple example just to show you how it works in action. What we have here, we have a drop-down where we can filter by different categories. And we also have an input field where we can also search the different items. The first thing which I'm doing is to define an array which will hold all the data that will be filtered and displayed. The next thing is our mediator. We are defining a class mediator, and this class coordinates interactions between the category dropdown field, also search input, and it holds the shared state for filtering and orchestrates updates. And we have the constructor. It stores reference to UI components, which are our colleagues. Register component method is method for UR components to register themselves with the mediator. The mediator provides itself back to the component so it can send messages. We have our notified method, which is centralized notification handler. All communications from colleagues comes through this method. The mediator then decides how to react and which other colleagues to update. Let's see it in action. Let's filter the dropdown and, for example, choose books category. And we see updating the UI. Let's see if it works for another category. And also we can see that it's working by the messages in the console. I'll go back to all categories and we'll search for electronics. Yeah, we have also update by searching in our search field. After any relevant changes, like in our input field, we are doing refiltering of the data and update the display, which we saw just a second ago. And this is the core logic managed by the mediator. We have here the filtering logic of the dropdown, which we saw that it's working as expected. And here we are applying the different categories for our filtering. And we are also applying search term for filter. Finally, we are notifying the results display component, our colleague, with the new filtered results. The mediator decides who to tell and what to tell. Here we are defining our colleague. This class provides a common method for interacting with the mediator. We are referencing to the mediator, which communicates with our colleague. Here we are setting the mediator, and we are also using the send method to message the mediator. Remember, colleagues don't communicate directly with each other, only through the mediator. And specific colleague implementation for the category dropdown, which is this. We are having a constructor, which is taking element ID and name, and it listens for changes and notify the mediator. When we are doing a change, this component only knows its own value change and sends it to the mediator. We also have a specific colleague implementation for the search input, which is this. Again, we have a constructor, which is getting element ID and name. And we use the input event for real-time updates as user types. On input change is handling the update of the mediator. This component only knows its own value changed and sends it to the mediator by referencing the search input. We have also specific colleague implementation for displaying the results. results display, extend our colleague class, and the method update is called by the mediator when it wants this colleague to react. And what we have to initialize the application, first we create the central mediator instance. Then we create instances of our UI components, our colleagues, which are not talking to each other. They are just communicating through the mediator. We have category dropdown, search input, and result display. We registered each component with the mediator. This establishes the communication channel. We are using mediator register component, and we are providing the specific component which have to be registered. And finally, we display all items when the page loads by using filter and display results. This was a simple example of how mediator pattern can be used in your application. And now let's see what are some of the advantages of using it. Let's summarize, and after all that we saw, as advantages of using mediator is that it reduces direct dependencies. This is primarily benefit. Components no longer need to know about each other, only about the mediator. This significantly reduces the spaghetti code problem, improves readability of individual components, because components are less coupled. They are easier to extract and reuse in different parts of your application or even in other objects. Simplifies complex interactions. The mediator encapsulates the complex logic of how components interact. Instead of distributing this logic across many components, it's centralized and easier to understand and maintain. And it also provides a clear point of control and debugging for complex interaction scenarios. We saw the advantages. Now let's see what are the disadvantages and potential pitfalls. Mediator can become a God object. In the mediation logic, if the mediation logic becomes too complex or the mediator handles too many different types of interactions, it can become overly large and difficult to manage. This is the common anti-pattern to watch out for. It also might become a single point of failure, because all communication flows through the mediator. If there is a bug or issue in the mediator itself, it can affect a wide range of component interactions. It may also lead to increased complexity for simple interactions. For example, simple communication needs like the one-to-many of observer, introducing a mediator can be an overkill and add unnecessary complexity. And finally, harder to test collaborations. Testing the mediator's logic can sometimes involve setting up many mock colleagues. So the mediator pattern is powerful, especially for coordinating interactions in complex UIs. It's about finding the right balance and not over-applying it. It's about finding the balance. And now let's look at our third and final pattern for today, one that helps us process data or requests through a series of steps, adding functionality at each stage. And this is the middleware pattern. You might have heard of it in the context of backend framework like Node.js, Express, but it's incredibly useful in the frontend too, especially with state management libraries or custom data flows. The observer pattern is about one-to-many notification, and the mediator is about centralized communication between many components. Now, The middleware is about processing data or a request through a pipeline of sequential functions. Each function in the pipeline, which we call middleware, performs a specific task and then passes control to the next function in the chain. Each middleware function has the opportunity to perform some operation, modify the data or request, and execute the next middleware in the chain or stop the chain. The best analogy for middleware is an assembly line or a series of security checkpoints. Imagine a package moving down an assembly line. At each station, each middleware, a different worker function performs a specific task. One adds a label, another scans it, a third puts it into a box. The package is passed from one station to the next until it's ready. Or think about going through security at an airport. You first show your ID, then your boarding pass, then your bags go through an X-ray, then you walk through a metal detector. Each step is a middleware function performing a specific check or transformation before letting you proceed to the next step. This pattern is fantastic for handling cross-cutting concerns, things like logging, authentication, validation, or data transformation in a highly modular and extensible way. While the middleware pattern is very common in server-side framework like Express.js in Node.js for handling HTTP requests and responses, the core concept of a sequential processing pipeline is equally applicable to client-side data manipulation, state management, or event processing. Now let's see what are the use cases in Frontend. The first is Redux middleware. This is a prime example. In a Redux application, middleware sits between dispatching an action and the action reaching the reducer. It's used for handling side effects like API calls with Redux Dunk or Saga, logging actions, analytics, or modifying actions before they hit the store. The second use case of middleware is in API requests and response handling. When you make an HTTP request, you might want to perform certain actions before sending it, like adding an authorization header, setting a timeout, and after receiving a response, like for example, we can log an error, data passing, token refreshing. Middleware can elegantly manage this pipeline. The next use case is in form validation pipelines. Instead of one giant validation function, you could have a series of middleware functions. One checks for required fields, another validates email format, another checks password strength. Each one processes the form data and either passes it along or returns an error. And finally, custom event processing. If you have a complex custom event system, middleware can intercept events, enrich them with additional data, filter them, or transform them before they reach their final listeners. The power lies in its modularity. Each piece of middleware is a self-contained unit of logic, making it easy to add, remove, or reorder steps in your process without affecting other parts of your code. Now let's go to our code example. So here we are creating a middleware pipeline function that orchestrates, it takes an array of middleware functions and returns a new function. Each middleware function typically takes context next as arguments. Context is the data being processed, which can be modified by the middleware. Next is the function to call the next middleware in the pipeline. Here, important thing is the index. Index helps ensure Next is coded correctly and only once per middleware. And as you can see here, the index is -1. It tracks the current middleware index in the chain and should be less than index or equal to it. The dispatch function is the core of the pipeline execution. It recursively code to move through the middleware chain. And it also prevents Next from being called multiple times or after the chain is done. Here the index updates the index to the currently executing middleware. And if there is no more middleware, the pipeline is complete. And we are returning the current state of the context. Here we are executing the current middleware. The middleware is expected to return the result of its operation, which should be typically the result of calling the next function in the chain. We provide current context to the middleware and next function. The next function, let me just expand. The next function is, when it's called by the middleware, will advance the pipeline. And we set the next context to current context in case the middleware calls next without other context. And we are also console logging in case of error. In real application, you might want to have more sophisticated error handling. And here we are just throwing an error. And we are stopping the pipeline. Finally, we start the pipeline by invoking dispatch with the first middleware. Here index is 0 and the initial context. Each middleware now explicitly returns the result of next or final context. Here we are logging the middleware to the incoming context, which is the current data which is being processed. We have a function, this function logger middleware, to call the next middleware and the context returned by the next middleware in the chain. We call the next middleware and return its result. And we are also ensuring the result from down the chain is returned. Here we are validating our middleware with the context value. And if it's invalid, it short-circuits the pipeline by returning the context with an error. And also, if this is the error, and if it's valid, pass the context to the middleware and return its result. Here we are using the transform context value and by doubling it if it's a number. And we are calling the next middleware, the context after transformation or the result from the next middleware. We pass the modified context to the next middleware and return its result. And we also are formatting the middleware in this block of code to add status property to the context. The current data which is being processed, and we are also using the next function to call the next middleware. We pass the modified context to the next middleware and return the result. And we also are initializing a response object with the context. we pass control to the next middleware, which might add to the response or process data and capture the result from down the chain. This part runs after the subsequent middlewares have completed due to next returning, and it modifies the result obtained from the rest of the pipeline. Finally, we are returning the result with the potentially finalized context. Here's how we are creating the pipeline. We use the create middleware pipeline where we are passing the over middleware, the validator middleware, all these functions which we already discussed, transform middleware, and formatter middleware. And finally, to make sure that everything is working, we are console logging the results. Here we have our final response pipeline, which logs the initial state, initializes response, then finalizes it after inner logic, and we have a simple middleware to process some data. If the data has been processed centrally, we are also console logging the process data and return the next context. Let's see if everything is working. Yes, here we have the objects which are returned by our middleware. Now let's see what are the advantages of using the middleware. I think I pressed the wrong button. So the first thing of using middleware is modularity. Each middleware is a small, focused unit of functionality. This makes your code more organized and easier to understand. The next one is extensibility. You can easily add new middleware functions to the pipeline without modifying existing ones. This adheres to the open-closed principle. We also have a reusability of logic. Middleware functions can often be reused across different pipelines or different parts of our application where similar processing steps are needed. We also have a separation of concerns. Cross-cutting concerns like logging, authentication, error handling can be neatly separated into their own middleware function, keeping your core application logic cleaner. And finally, we have flexibility in flow control. Middleware can modify data, execute side effects, or stop the chain, providing fine-grained control over the processing flow. Now let's see the disadvantages. And the first is that it can introduce complexity. For very simple operations, a middleware pipeline might be an over-engineered solution, adding unnecessary overhead. Debugging can be harder to trace. When you have many layers of middleware, tracing the exact flow of data and understanding which middleware caused a particular issue can become challenging, especially if errors are not handled gracefully within the pipeline. And finally, implicit order dependency. The order of middleware in the pipeline often matters significantly. If functions are placed in the wrong order, unintended behavior or errors can occur. The middleware pattern is excellent for building robust, extensible processing chains. It's prevalent in frameworks, but understanding its core mechanics allow you to apply it effectively in your own custom solutions. And that wraps up our second session from Design Patterns Study Group on the Observer, Mediator, and Middleware pattern. These three patterns are incredibly valuable tools in your JavaScript toolkit. They might seem distinct, but they all share a common goal, helping you manage relationships and communication in your JavaScript applications in a clean, efficient, and scalable way. They allow you to write code that's easier to maintain, understand, and extend as your projects grow. I encourage you to look for opportunities to apply these patterns in your own code bases. Start small, try refactoring a tricky communication flow, and you quickly see the benefits. And don't forget to learn more about the other design patterns in patterns.dev, because we are using this website as our core for this study group. Thank you.
Violina, thank you so much. It was amazing session, very inspiring, very informative. We love the examples. And of course, we're having a couple of questions for you. I'm going to move to the questions. So Amshara is asking, can you briefly explain the first two design patterns again? They seem pretty similar to me. I'm having a hard time differentiating the two.
And Sarah, are you talking about the observer and mediator?
Yes.
So the observer pattern is the core of the observer pattern is one-to-many connections, and in the mediator pattern we have a mediator which centralizes the connections, and we have the different component or colleagues which are talking to the mediator but are not talking to each other. In the observer is a bit different, sorry. We have the subject, which is our observer, and we have events, and which are sending information to our observers.
All right, thank you.
Thank you, Sarah, for the great question. We do have a couple of more questions. So how do you decide? This is very similar. How do you decide whether to use a mediator or middleware pattern when decoupling components?
Well, they are pretty similar, and at the same time, they serve different purposes. And usually, if you're working in a team, you have to decide this not by yourself, but you have to discuss it with your colleagues. What will be the most suitable pattern? Would be a middleware or a mediator? And middleware is more like a backend part of the application, but it also can be used in frameworks like Redux, for example, Redux, Saga. They benefit of the middleware.
Thank you, Violina. Great answer. And we know that you're a very well experienced mobile developer with more than 10 years of experience. We wanted to hear from you a real world example from your experience where one of those patterns significantly improve the code base.
Well, I said that last time, and I will probably repeat it again. Sometimes you don't have to overuse the design patterns, because something can be approached with less code without using a design pattern, but in general, using the different design patterns which we are going to discuss in our study group can significantly improve the way you write code, the way you think about writing the code, because it's not about just creating an object and not thinking what will happen afterwards. Everything should be connected, everything should be well designed before even starting to write the code, because I think this is how the developer role will change over time. We see that the AI is advancing very fast, and we can generate code, but usually this code is long spaghetti code, which is hard to maintain. That's where the good developer knowledge comes in place. You have to know what is better, what is best actually, not better, what is best for your application. You have to have the knowledge which AI sometimes cannot replace, and you have to think in a different way. If I create an object which can communicate with other objects, what will be the concerns, what will be the benefits? So it's not about writing the code, it's how you structure your application actually. I don't know if this explains your question.
Yes. It was a great answer, and you inspire us in giving us a hope that AI is not going to pass us, and we going to learn more of the design patterns so we can stand out. Thank you so much, Violina. We don't have more questions. It was very, very informative, and we are very thankful to have you as a speaker today. Thank you so much, everyone.